Today we'll be proving the sine law, which is a helpful formula that helps us figure out the angles or the sides of a triangle that isn't a right angle triangle. Now, because this is not a right angle triangle, it is labeled a little bit differently, but I'll explain how I labeled it. So, the capital letters represent the angles. So capital A, capital C, and capital B all are the corresponding angles of the triangle. So angle, angle, angle. The lowercase letters represent the sides. So B is all this, A is all this, and C is all of this. The letters are the matching opposite angles to its side. So what I mean here is that capital A is right across from A, capital C is right across from C, and capital B is across from B. So that's how I label my triangle. Now, because this is not a right angle triangle, we can't use the tools that we traditionally have, such as the sine, cosine, or the Pythagorean theorem. But if we cut this triangle into two right angle triangles, like this, and call this height h, because we don't really know what this is, but let's just call it h for now and see what happens. Now we can use the tools that we're familiar with. So, as the name suggests, we're going to use the sine function. So let's use it. Sine A is equal to the opposite over the hypotenuse, which is B. Now, the reason why this is the hypotenuse is because we're ignoring this part of the right angle triangle, so don't ignore this for now. But this is the longest side, therefore it is the hypotenuse. This is the opposite side, which is h. Now for sine B, the opposite here is the height, so h. So sine B is equal to h over the hypotenuse, which is a, which is the longest side. Okay. On the left side here, let's multiply both sides by b and see what happens. So we get b sine A is equal to h. And on the right here, let's multiply both sides by a. These two cancel out, and we end up getting a sine B is equal to h. Okay, now I have to observe something important. As you can see here, b sine A is equal to h. A sine B is also equal to h. Therefore, these two must be the same thing if they both equal h. So let's write it that way. B sine A is equal to A sine B. Now let's divide both sides by b. So this one will cancel out. And let's divide both sides by a. And these will cancel out. And we get our final formula. Sine A over A is equal to sine B over B. Now your textbook probably also shows a sine C over C. Now this part of the formula we actually have to derive a bit differently, because if you notice from before, A and B are acute angles, which are angles under 90 degrees. But C is an angle over 90 degrees. So we have to be a bit more creative with how we derive this part of the formula. So we have our triangle, same as before, and we're going to do something a little bit different to it. We're going to rotate it, like this, and I'm going to add my angles to it. Now the reason why I did that is so it's easier to visualize what I'm about to do to this triangle next. So we're going to turn this into a right angle triangle. So let's have a line here. Let's call that H. And this unknown region, we're going to call this K. Something important here. Now we have an extra angle here. It's an extension of C1. We're going to call it C2. Now, if you notice something about the angles of C1 and C2, if you add C1 and C2, you get 180 degrees. Now these angles are supplementary angles, which means that C1 plus C2 equals 180 degrees. what's important about these angles is that if you do a trig function on supplementary angles, you will actually get the same result. So sine of C1 would equal to sine of C2 because they're supplementary angles. Let's use that to our advantage here. Once again, we're using the sine, so let's do it. Sine of B is equal to the opposite, which is, well, now it's all the way over here, so it's equal to H over C, which is the hypotenuse. And now we're going to do sine of C2 right here. Sine of C2 is also equal to sine of C1, so we can just write sine of C. But sine of C is equal to H over the hypotenuse, which is B. And let's multiply both sides by C. And over here, let's multiply both sides by B. And we notice that both these and this are equal. So we're going to get C sine B is equal to B sine C. Once again, we're going to divide both sides by C. Both get cancelled. And we're going to divide both sides by B. Both sides get cancelled. And we get our formula, which is sine of B over B is equal to sine of C over C. Now, but we just derived earlier that sine of B over B is equal to sine A over A. So that means sine A over A equals to sine B over B, which is equal to sine C over C. And that, my friends, is the sine law.